Hi friends, my name is K. Sairaj from CSC Department A section. Today my topic is justify why an engineering student need to know about Schrodinger and his contribution to quantum physics. Erwin Schrodinger. Erwin Schrodinger was a Nobel Prize winning Austrian physicist whose groundbreaking wave equation changed the face of quantum theory. From 1906 to 1910 was a student at University of Vienna, during which time he came under the strong influence of Fritz Hazel-Hall, who was Boltzmann's successor. Schrodinger work. In Niels Bohr theory of atom, electron absorbs and emit radiation of fixed wavelength when jumping between orbits around a nucleus. The theory provided a good description of spectrum created by the hydrogen atom but needed to be developed to suit more complicated atoms and molecules, assuming that matter could be regarded as both particles and waves. In 1926, Erwin Schrodinger formulated a wave equation that accurately calculated the energy levels of electron in atoms. The Schrodinger equation. The equation describes what electrons do under almost any circumstance. To do so, one needs to insert a term that describes the situation the V. When an electron is somewhere that nothing happens, V is 0. If it gets close to an atom nucleus, we will have a different formula. The mathematical side is beyond the scope of this article, but the result fall right within the boundaries of our interest. Initially, it shows how complex the atom orbitals are, with their varying shapes as either spheres of the shape of dumbbells. PSI in the Schrodinger's equation. PSI or wave equation is the most important part of Schrodinger equation. The answer. The solution to the Schrodinger equation is intended to describe the electron, and there can be infinite number of solutions. However, the focus here is on PSI, which equals the square root of Pi times e to the minus r, where r is related to the distance from the center of the atom. Classical versus quantum mechanics. Classical mechanics expects an electron to be like a planet orbiting the sun at a specific radius with a specific speed. The quantum realm not only explains why the classical view is wrong but also shows how the reality is. Quantum mechanics here is built around probabilities. The wave function or PSI is used to calculate these probabilities. However, the tricky point here is to successfully avoid interpreting the quantum realm with classical tools and expectations. The collapse of the wave function. In the experiment where one photon and one electron were shot at narrow slits, each acted like particles. However, even though electrons or photons were considered, the pattern looked like a wave. Same thing happens inside an atom. The electron can simultaneously be everywhere that the wave function says it can be. However, it is actually only at the point where it is detected. This is when the wave function collapses. This means that when the electron is finally detected, the wave function's probabilities are no longer valid for places where the electron is not located. Thus, the Schrodinger equation made the complex and confusing world of quantum physics a bit more predictable and understandable. Nobel Prize winner. In 1927, Schrodinger left his position at Zurich for a new prestigious opportunity at the University of Berlin, where he met Albert Einstein. He held this position until 1933, opting to live upon the rise of Adolf Hitler's Nazi Party and the related persecution Jewish citizens. Shortly after joining the faculty of Oxford University in England, Schrodinger learned that he had won 1933 Nobel Prize in Physics, sharing the award with another quantum theorist Paul M. Dirac. In his Nobel Prize acceptance speech, Schrodinger stated that his mentor Hazel would be accepting the award if he didn't die during World War. Thank you.